the users of any devices, they shouldn't deal with firewall into their daily base tasks, okay? But of course, we as software engineers, we should be able to understand what firewalls are, and also for some of the jobs that you apply, you might be even designing firewalls, okay? There are actually many third-party services that, for example, if I'm having a network and I want to add some level of security to my network, I might want to implement firewall from a third-party provider. And actually today you're really going to see other services that you're familiar with, that they're also doing the work of a firewall, okay? So let's get started. Okay, so firewall is pretty much what is controlling the traffic that is going to your device or to your network. So firewalls are built to filter the traffic, so some of the traffic that comes to you from the internet, or when we're talking about the firewalls, we're talking about the bad internet, right? This internet that is really exposing the vulnerabilities of your system, and an attacker could penetrate it into your network. So this is why firewalls are very important. So their main goal is to limit some of the services or the traffic that is going to your network, okay? So any message that comes to your network, they're going to filter it based on the message. They're going to decide, okay, we're allowing this to the network, or no, we don't want this message to go to a particular network, right? So there are many different implementations of the firewall based on the different layers, the different networking layers, okay? So before starting, do you know some of the layers that we're using when we're communicating? So this would be the layers from the OSI model, right? Any ideas on what the different layers are? I think I asked this maybe before. So somebody says security, somebody says network. Okay, network, good. Physical, yes. Anything else?
The transport layer.
Transport, exactly, yes. Other layers. So there is also, you said most of those. Yeah, presentation layer we have as well. We also have application layer, right? So data link layer as well. So pretty much on all of those layers, maybe except on the physical layer, we're implementing firewalls, okay? So some of you mentioned network layer, transport layer. So let's say on the network layer, what is the data that we deal with the most on the network layer? What do you think? So, okay, so in the network layer, we're mainly dealing with IP addresses, right? So the IP is pretty much what defines a network, or how a particular network can be found, or a particular device. Okay, so for example, in the transport layer, what we're dealing with there? Any ideas? Okay, so in the transport layer, we're dealing with ports, right? So you might know the particular network, but the different applications, they're communicating through ports, okay? And this is happening at the network layer. So this means that what we want to do is really to filter the IP addresses, the ports, and also other types of data on the different layers. So when we filter those, we can pretty much say, okay, this specific network is a bad network, so I want to stop the connection with it. Or on this particular port, we're having an application that might break my device, so I don't want to receive or send data to this particular port. And instead of you making this decision, firewalls are doing this for you. Okay, so they automatically limit some of the connections, some of the applications that your network can use in order to protect you. This is the whole idea. Okay. So how firewalls are implemented. I will now talk about the general idea on how a firewall works on a network, for example. So normally, here you can see on the figure, we have the internet, and this is a network, right? You have a router and all that. And then you have the devices right here. So before the traffic from the internet reaches your network, it goes to a firewall, or the device that goes on is called a bastion host. Okay, so the bastion host is pretty much, you can imagine it as a choke point. So everything goes through this bastion host or firewall, and then based on the scripts and the decisions made inside this host that is not inside your network, okay, you're receiving certain traffic or you're denying some particular traffic. Okay, and another example, for example, it could be a VPN, right? So let's say you have a company with multiple different seats. So you have one network right here, you have another one right here, then you also have a VPN also implemented to another network that is remote. So in that case, for example, you can have a VPN tunnel with a firewall as well. So the VPN can be also used as a firewall tool. Okay, and we're going to look at specific implementations of those. Now, the two main policies that you also see from the script that I will show you later. So the two main policies of the firewalls are deny everything that is not specified and allow everything that is not specified. So when we deny everything that is not specified, this means that you have a list of networks, port numbers, and other data that you're allowing to your network, and you're pretty much denying everything else. This is one of the policies. The other popular policy is allow everything, which means that you're allowing all the traffic to your network or to your device that is not specifically listed somewhere. Okay, so let's say if you have a list with IP addresses that you don't want to deal with, only those IP addresses, or only the traffic from those IP addresses is not going to be accepted on your network. And how it's not going to be accepted? So every packet that you receive from such a bad network or service is going to be simply dropped, and it will never reach your own network or your own device. And this is really a very simple way to secure your systems, right? If you never accept the packet, you're never going to read the packet. So there is no chance that this packet or this data that comes to you, there is no chance that it can damage your device, right? So this is why firewalls are so efficient. Yep. So somebody raise a hand.
I'm curious about DNS filtering and firewalls. Is it like this? Is it the same thing? You can filter websites into your network just by DNS.
Yeah.
Is that using the firewall, or is that a different?
No, yeah, this is exactly also a firewall. So you can filter certain websites. So website, if you imagine it, it has a name, yes, right? But behind this name there is an IP address. So you can filter the name of the website, which is going to also filter the IP address of the website, and then you cannot access it, so you cannot receive information from it, and you cannot also send information to this website as well. So this is an implementation of the firewall as well. Yeah, when we talk about websites. Okay, so we talked about a few, but here's like a full list of implementations on firewalls based on the layer. Okay, so for example, in the application layer, you have application level gateways, You have proxy servers like the SOX proxy server, which we're going to talk about. On the transport layer, you have the packet filtering, which is filtering based on the protocols TCP, UDP, ICMP as well. Then on the network layer, you have the NAT, which is having multiple functions, but one of the functions of the NAT is also as firewall. It protects your internal IP addresses being exposed to the world. Okay. We also have the IP filtering as well. On the data link layer, we have MAC address filtering, okay, which is a specific address of on the data link layer of your device. Okay. And on the physical layer, you don't normally have firewalls, because on the physical layer we're simply breaking down the message into bits and transmit it to the medium, right? So for this reason, on the physical layer, since there is no compiled information of the packet that we can read, this is the reason on the physical layer we don't normally implement firewalls, right? There are other security things there that you can implement. Okay. So we're gonna start by talking about packet inspection firewalls, and there are pretty much two main types of packet filtering that we can have. Okay, so this is stateless filtering, okay, and the other one is the stateful filtering. So in the stateless filtering, we don't normally care about what is inside the packet. So our firewall is not going to read the packet and the information inside. Okay. So this means that we are deciding whether the packet is going to be dropped or not based on the context in which this packet is sent, but simply because of the service, let's say, we don't like the IP address or we don't like the port. Okay, we don't care about anything else. In the stateful filtering, we care about the context. And what context means? So we care about the time at which this packet has been sent. We care about the data that this packet contains, right? All of those things. So based on those two techniques, okay, there are different firewall systems that are implemented, right? So in general, in all the packets, we normally care about the source address, the destination address, the protocol. Actually, this is very important, the protocol that is used at the transport layer, whether it's TCP or UDP. Okay, we sometimes care about the payload of this packet if we read it. Okay, so those are really things that we put into consideration. And next, I'm going to talk about how you can really use this data to decide whether you want to use certain service or not. Okay. Okay. So firstly, we're going to talk about the IP and the port filtering. Okay. And IP filtering, I already explained, it's a very simple one. So you can have policy like the one on the table on the top, right? So let's say you can have a destination IP here defined, and then your policy can be to allow all the traffic from this IP, but let's say to deny all the IP from all the traffic from the other IP. Okay, so simply you're specifying a list of IPs, and then you filter the traffic based on that. Okay, so then if we have IP filtering, why do we need port filtering? Okay, so could you tell me for some reasons why would we want to receive services from certain IP, but we're going to filter those services based on port? Why would we do that? So the reason for us to do that is that sometimes we actually want to imagine the situation with a website. We want to go to a specific website, but we want to use just certain services of this website. Okay, so we want to protect ourselves from some of the applications, but we want to use some other applications, right? So to implement that, you can specify on your system that you don't really care about the IP, but you care about the port number. Okay, so let's say everything that comes on port number 80, okay, which is usually HTTP request and responses, you want to allow. Okay, but let's say you want to deny the SSL communication. Okay, for example, the reason might be that you don't want to receive messages that are having UDP protocol in the transport layer. Okay, so you want to remove those. One very common real life example of that is the emailing system. So for example, let's say if I have a device which accesses internet, right? Many people might block the internet, the email transmission port, because if this port is opened, I can send as many emails to as many users that I like, okay, which might flood their systems. Okay, so if I want to protect myself from that, I'm just going to block the port for sending emails, and in that way I'm not going to receive emails from everywhere, right? If, for example, I create a VM on the cloud, in most cases, if they don't know you, the first thing that they are going to do, they are going to block the port with which you can send emails. Because if they don't do that, I can send emails to, let's say, 300,000 users from my virtual machine at once. I can write a script for that, okay? And then I can flood their server and the server of the people to which I sent emails. So for that reason, you might want to block this port if you're a cloud provider, for example. Okay, and when we're talking about port filtering, the same strategy applies as normal firewalls. So we have allow listing and deny listing. Okay, so on the allow listing, only specific ports are permitted for communication, while in the deny listing, only the ports that are listed are not permitted, while all the rest of the ports are allowed. Okay? All right. So, except the IP address and the port filtering, when we're doing so every communication normally has a few steps. For example, imagine if you want to do a TCP communication, which is a secure communication. In the TCP, there are multiple messages that have been exchanged during the communication. For example, let's say I want to send a file somewhere, or I want to receive a file. To do that, I will need to send multiple packets, okay? Because the whole file cannot be sent at once. So maybe I will send 100 packets. Each packet will have a small bit of this file that I want to send, okay? So to secure the file sending from somebody that wants to compromise this connection, we normally care about the SYN message and the acknowledge message. So just to recap, when we're doing a TCP connection, the sender firstly sends a SYN message to the receiver, okay? Then the receiver sends a acknowledge message that they receive our SYN message, and also accept acknowledge, they're also sending us a SYN message as well. Then we need to acknowledge their SYN message as well, and in that way both parties now acknowledge themselves and they can start sending packets to each other, okay? So once we start sending the packets, each packet have a sequence number, right? So let's say if a file is broken on 100 pieces, okay, the first packet will have sequence number 1, the second packet will have sequence number 2. That way we know which packet to expect. Another important thing is that the very first packet is going to have an acknowledgement bit of 0. Acknowledgement bit of 0 means that we want to initiate connection, and this is only for the first packet. Okay, so if we have acknowledgement packet of 1, this means that the packet that we're sending has already established connection, so we're just sending, so let's say for 100 packets, the first packet is going to be with acknowledgement bit of 0, and then the rest will have acknowledgement bit of 1 because the connection is already established. So based on the sequence number and the acknowledgement bit, we can do additional filtering. And we need to do this filtering because while I'm sending you, let's say, the 5th packet, some attacker might come in and might replicate my 6th packet and send it instead of me, right? So if they do that, the receiver will receive some wrong data and they will be confused, okay? Or their system might get vulnerable for that reason. So another way of implementing firewalls is really monitoring the sequence numbers and the acknowledgement packets. This is a more dynamic way for implementing firewalls. Okay, so for example, if I expect sequence number 16, right, from this IP address and this port number, okay, I'm not going to accept anything that has a different sequence number. Or for example, I can create a policy that will accept only acknowledgement bits equal to 1. 1 means that connection has already been established. Okay, so this means that once I start a TCP transfer between a sender and receiver, I don't want to establish any new connections. So I'm not going to accept any packets that are having the acknowledgement bit equal to 0. So I'm going to deny them. Okay, so that way we are using the same IP address, the same port number, but we can also filter on those two numbers for more dynamic implementation of the firewalls. Okay, does this make sense? Okay, good. So let's then see what are some of the problems when we do packet filtering implementing firewalls. So really there is one very big issue when we're transmitting packets over the internet, and this is when we use the UDP protocol. So in UDP, unlike on the TCP, we are just sending a message, but we don't establish a connection before that. So we just shoot UDP packets and we hope they get to the destination. Okay, we don't have information whether they're received or not. This means that any messages sent with the UDP protocol don't have acknowledgement bit or sequence number. So this means this cannot be filtered. So for this reason, the UDP messages are more vulnerable to attacks comparing to the TCP, right? Because we cannot do this dynamic filtering in the firewall. Okay. Also, another thing that we should care about is that the packet filtering doesn't really see how legit the messages are, okay, because it doesn't really read the payload of those messages. So we're looking at the header and we're looking at the IP address, port number, sequence number, and so on, but we don't really know what is inside the payload. Okay, so this is another weakness of the packet filtering. Okay, so let's talk now about how really firewalls are implemented in the real life. Okay, so in most cases, firewalls are implemented as something called proxy servers. So I assume that you heard about proxy servers already, right? You heard the term. And do you know what proxy servers do more or less? So the proxy servers are really based on what we discussed already. So as you can see here, your network will have some internal IP address, right? Then it will go to the proxy server, which will be our firewall. And what the proxy server will do, they will change the IP address, the internal IP address, with their own IP address. So really what's going to be visible to the internet is going to be the IP address of the proxy server, which is something that is very valuable because the IP address of the sender is always going to be hidden for the public. So nobody will actually find out what your actual IP address is. They will see only the IP address of the proxy server right here. So when a packet is received from the internet, it will go to the proxy server. The proxy server will change the destination IP address to the one of your laptop, okay, and it will send the packet to you. Okay, so the proxy server has exactly this capability of really filtering the traffic based on the different services. For example, you probably know that there are some services that are always staying on the same port. For example, on port 80, you have the HTTP. On port 20, you have the FTP, the file transfer protocol, right? The mail is always on port 25. So the proxy server can really close those ports for the public, and in that way, it can limit those services from being exchanged with the internal network. Okay. Okay. So the first type of proxy that has been developed actually quite early, this is the SOX proxy. Okay. So the SOX proxy has the ability to limit the applications that you don't want to use on your internal network. Okay, so you can specify the applications there in the filtering protocol, and then the SOX proxy will limit those applications that are coming from the internet to your internal network. The lack of the capabilities of the SOX proxy is that the SOX doesn't really read the packet. So there you simply specify the policy, and the SOX proxy really just limits the type of services that you don't want to receive without opening them, without opening the messages. So this means that the SOX proxy is quite fast because it doesn't always need to open every single message. It doesn't need to authenticate the message, but it simply rejects any message that comes, for example, from a network that you don't want to reach. Actually, many companies are applying a policy, for example, based on when an IP or when a host name has been created. For example, if you create a website that is brand new, okay, some companies might have policy to limit the traffic only from websites that have been created more than 1 year ago. Actually, in fact, the company that I work in is currently using this type of policy. So I think if there is a website that has been created sooner than 3 months ago, you will not be able to access it from the company computer, just because this website might be dangerous as it is brand new, right? But for example, websites like Google, Yahoo, that have been on the market for more time, they will allow the traffic to reach your device. So this is a very simple technique really to limit the traffic. Okay, so the next type of real life firewall is the VPN. So who can tell me what is VPN like with simple words, more or less? Come on, guys, I know you know it for sure.
Is it allows you to, in one sense, it masks your IP address. You can use it it looks like your connection is coming from a different IP address, or like in a remote office situation, like you said,
Yeah.
connect a VPN to join the company network from distance.
Exactly, yes. And actually, many companies are using VPNs as an additional level of security, right? So when you want to access any network from your company laptop, you have in the background a VPN running. So your traffic will be allocated to the VPN server, okay, by doing a secure VPN tunnel, okay. And that way, the first important thing is that all the data that is outgoing from you, everybody else will see it as it goes from the actual VPN. And the second important thing is that the VPN tunnel actually has an encryption. Okay, so even if somebody breaks into the VPN, all the messages that are exchanged between the VPN and your internal network are encrypted. So this adds an extra level of security. Okay, and a VPN can be located at any location, right? So you can use a VPN located in Germany or somewhere in Asia and so on. Although it is normally a good practice to use a VPN that is at least close to you in some way, because that way the traffic that's coming to you is actually going to come faster. Okay, so even though we're using internet, and I guess you imagine internet, everything happens instantly. If the physical VPN is actually far from you, okay, everything that you're using on your device, it will appear to you to be slower. Okay, so it is good, for example, if you're in US, to have a VPN that is also located in US, just so it is close to you, but still an attacker cannot determine your IP address. Okay, so another two very important, actually, especially the second one is implemented everywhere. But the two types of firewalls are the Soho firewall and also the NAT-based firewall. Okay, so the Soho firewall is normally implemented on very small networks. Okay, so for example, a network that will consist of a hub, switch, a bridge, right, and it will connect a few devices, okay, might have a Soho router right here, okay, which is going to connect this small network to the ISP, the internet service provider, okay. And the other very popular network for a very popular firewall for small networks is actually a firewall that everyone has at home, and this is the NAT firewall. So normally, do you know what NAT does? Okay, so normally the idea for implementing NAT initially was not to implement it as a firewall, but simply we needed that because just the available IP addresses on the internet was getting too low, right? So let's say from the IPv4 IP address, which is what is seen as, you know, four numbers separated by dot, those type of IP addresses are only 4 billion, okay. And in the beginning of the internet, nobody expected that we will actually reach that many IP addresses, but now the IPv4 IP addresses are almost done, right? They're almost finished, so there are no more available IP addresses. So for this reason, we have the NAT, which means that let's say if you have a network, okay, every device on this network normally will have a different IP address. Okay, so let's say at home, if you have 4 laptops, those 4 laptops will have each different IP address. Okay, so if we don't have NAT, all of those 4 IP addresses will be exposed to the internet. Okay, so let's say if you go to the internet from laptop A, okay, everybody in the internet will see the IP address of this laptop. If you go from laptop B everybody will see the specific IP address of this particular laptop. So what NAT does, and this is something implemented in any router that you have at home, what NAT does is it creates an internal network. Okay, so the IP addresses of your devices at home, okay, might be the same as the IP addresses at your friend's home, okay, but they are not going to be exposed in the public. Okay, so what NAT does is, let's say if you have 4 laptops, they will have internal IP addresses valid just for your current network. So when you want to communicate with the internet, okay, you have, as you can see, an internal IP address of every device, okay, and then you have only one public IP address that is going to be the IP address of the whole network. So you probably know that when you want to connect to the internet from your home, every home has only one IP address. Okay, so how this happens if you're using multiple devices? So NAT, which is implemented in every router, has a table. Okay, and in this table, this table is updated automatically when you connect a new device. So in this table, NAT can have, for example, the IP address of laptop 1. So if I want to send a packet to the internet, the packet will go to the router, okay, and then NAT will change my internal IP address, okay, with our public IP address that reaches the internet. Okay, when a packet comes from the internet, it will go to the NAT firewall. The NAT firewall will look up at the table and it will see which device have requested that service from the internet. So the packet will come from the internet with the destination address of the NAT firewall, and then in the NAT firewall, the destination address will change to the private IP address of your laptop. Okay, so for this reason, the NAT technology is really used in 2 ways. The first one, to save the IP addresses, and secondly, and most importantly, not to expose your IP address to the public. Now, the final thing we're going to talk about is something called the demilitarized zone, or the DMZ. So, for example, if you have a company and you have multiple customers, sometimes you want your customers to be able to access some of your internal services, right? For example, let's say if you're let's say if you're working for Cisco and you have a supplier that is fixing your servers, right? You want this supplier to be able to access the databases that include some information about the servers that Cisco builds. That's internal. So how do you allow this supplier, okay, in secure way to access this type of information? So to do that, you can build something called demilitarized zone, or DMZ. So what really DMZ is, it is an additional network of services that are only inside the DMZ. So for example, you can say, I want all the file transfers and all the web transfers to be in this demilitarized zone. So I'm going to have them away from my internal network and I'm going to put them somewhere else so other people can also access them. Obviously, when you have something like this, you need to be extra careful, because if somebody gets into the DMZ that is not allowed, then this is a problem. Okay, so we need some extra level of security for the DMZ. Okay, so for this reason, we're going to have here a firewall that is called three-pronged firewall. And it's called like this because it's really accessed from 3 sides. One of them is from the internet, one of them is from the DMZ, and then from our private network. Okay, so you can imagine this firewall as built from 3 routers, each of those routers with their own protocols denying policy. Okay, so based on where the traffic comes from, whether it comes from the internet, from the DMZ, or from the private network, those routers will have some conditions based on which the traffic will be filtered. So DMZ is usually expensive to implement, and these are the disadvantages. And of course, the complexity of your network might increase when you apply DMZ, but it also allows extra level of security while providing some of your services to the public as well. Okay, there is actually another implementation of the DMZ that you can see here. For example, you can have one firewall that is between the public and the DMZ, okay, and then you can have another firewall between the DMZ and the private network. Okay, so you can have two different firewalls that are filtering the traffic more and more. Okay, so let's say if I want to communicate from the internal network to the DMZ, I'm going to pass this firewall that has a specific policy based on this connection, and then the other firewall will have a completely different policy because it is between the public, okay, and my local DMZ that is located and the DMZ that is located, at another location, and that allows access to those services. So yeah, those are pretty much the different implementations. There is also this type of structure which applies something called intrusion detection system as part of the firewall, and you can have one before the firewall, so between the internet and the firewall, and between the firewall and the internal network as well. Okay, so we pretty much have these two implementations plus the third one right here. Okay, but the whole idea is, as I said, to have some of your services available to your specific customers or to other networks that you want to specify. All right, and finally, some of the firewall services that are not implemented in your device, for example, as we discussed, obviously Windows has a built-in firewall that is limiting the traffic. But for example, if you want some additional features for a company that can be easily scaled and implemented, of course, there are web providers that provide firewalls as a service, okay, which is, for example, if you purchase on a VPN, okay, and in that way you don't need to build it yourself, but you can simply pay a small fee, and then you can use a VPN on your device, so nobody can really detect what your IP address is. Or another interesting portion of that is, for example, some services might be limited, let's say, for people living in US. So if you want to access those services, obviously you can get a VPN from another country or location where you are going to have those services, implemented. So also you can see that the firewalls are really some of the basis on how people from different locations can have access or be denied access from different websites or services, right? For example, if China wants to limit Facebook or other Western websites, they can easily do that, by simply tracking the location of the user, their IP address, and then simply blocking all the traffic from those services.
I'm curious about a specific type of blocking, I suppose you could call it. Is there a way, if let's say someone has created a site and they embed content from another site inside of their site, so the site they've created is on the allow list, but that what is embedded on their site would normally be on the deny list. Is there any way to handle something like that?
Yeah, very good question. So if you build your own website that is taking services from another website or from their API, right? You can actually do that. So let's say you create your website and your website is allowed, let's say in US, but then you're using services and data from a website that is not allowed. You can do that, and the users, when they visit your website, they will see those services. But it really depends how you do it. Okay, so if on your website you provide the information with links from this forbidden website, obviously those links, they're not going to work because they will redirect the users to the website that they shouldn't access. So this is not going to work. If you copy the data to your own server, then the users will be able to access this data. Okay, so then you would ask me probably, so since this is possible, right? Then everybody can do it. There is no problem, you can access data from everywhere. Yes, but if you do it and you provide the service, let's say in US, okay, when you're small, let's say you have small traffic to your website, maybe nobody will notice, but as your website gets more traffic, it gets also more attention. So at some point, the authorities are also going to block your website because it provides this data that they don't want the users, for example, in US to hold, right?
So is that would that be what you were saying then? Maybe a new website, if it's trying to do something like that, you could block based on, like your company does. It's a brand new website, we won't allow it.
Yes, yes.
But otherwise, if it's copied into that allowed website, there's not much that can be done until, like you say, it becomes
Yeah,
a known issue.
exactly, until it gets noticed, and then simply they're going to block your IP address for US, and then people will also not be able to go to your website as well.
Okay.
Like this is probably the most simple like real life example on exactly how the things are going if you try to do that. Yeah.
Yeah. Thank you.
All right, so this is all I wanted to share with you about the firewalls. You can see it also on the reference 4 into it's going to be uploaded in Blackboard. Okay, currently, and we're not going to cover this too much. I'm also not going to give this to you on the quiz. Currently, there are also strategies on implementing firewalls using AI. Okay, and there are some resources that are referencing to that, how AI can detect the traffic and then decide itself what it wants to limit and what it doesn't want to limit. Okay, but this is currently not implemented, especially for big corporations, because it is not that reliable yet. At some point it will become. So for this reason I left it into the reference, but I'm not going to give it into the assignment because yet it doesn't have that many real life implementations, right? But this is definitely some of the future of how in a dynamic way you can really limit traffic based on AI, right? Which also actually introduce some danger. So if the AI gets smart enough, it can really block us from accessing some information and allow us to access some other information based on what it wants. So for this reason, they're taking steps to implement those features, but they're going to be a very slow steps until there are enough policies made in order to allow this. So yeah, just wanted to make you aware about that. All right, so the next thing that we're going to do is we're going to implement a simple Python code. So I'm going to go again to the website programiz.com, okay, where we're going to implement a very simple code on firewalls. So what are we going to build today is something that is going to be built from two classes. One of them is going to be the rules class, where we're going to define specific rules on what traffic we're going to accept, and the other one is going to be the firewall class, which is going to use the rules in order to allow specific traffic to us, that is coming to us. Okay, so you can see how this is really implemented in real life. Of course, because we want to keep it simple, we are going to do a stateless firewall traffic detection. So we're going to care only about the header of the packets that we receive, okay? And we're not going to care about the information that is inside those packets. So another interesting thing you will see today is how to use really classes and objects. So this is going to be done in object-oriented programming. Okay, so you also see how this is implemented. First of all, guys, is any one of you familiar with what object-oriented programming is, how to implement objects, classes, those type of things? Yeah? Okay, good. I mean, even if you're not, it's gonna be a great experience for you to really see how object-oriented programming is implemented with Python. Okay, so I will just zoom in a little bit so you can see better, and then we can write the code. So for this code, you don't need any external libraries. It's just going to be working on its own. Okay, so firstly, the idea of object-oriented programming is simply you're able to transform the code into objects and classes, right? So for example, if we have the class human, okay, Martin is going to be an object of the class human. So the class human might have some features like hair, eyes, hands, okay, and also might have some functions like running, eating, those type of things. So really the class is going to the blueprint of what a human is. And if I want to create a new human of this class, then I can do it and I can call it how I like. Okay, so let's first create a blueprint of a firewall. So you can do that with Python by writing class. Okay, and I will name this class firewall. Okay, so firstly, I want every time when I create a new firewall, so a new actual firewall, I want this firewall from the beginning, once I create it, straight from there to have certain features immediately. And in Python, to specify features from the creation of an object, you need to define the init class. Okay, so if you have experience with other programming languages, this in our programming languages is called constructor. And what constructor does, it specifies certain features from the creation of the class. Okay, so what I will say here is that every time when a firewall is created, I want to do so self dot, I want to create a list of rules, an empty list of rules. Okay, so when I create a firewall, immediately to this firewall it will be assigned one list of rules. The self keyword means that this variable rules is internal for the class, so this lives inside the class, which means that if I define rules outside the class, this is going to be different. That's why we use the self keyword. So we know that we're talking only about what's happening inside. But for our exercise, to be honest, this is not going to be that important because we're not going to use that many variables. Okay, Now, inside the class, I'll create a function. And the function, when it is not this init function, that is the constructor, a function can be only called explicitly. So only if we call it ourselves. So the function will be called add rule. Okay, so I'll do self and then I'll do rule. Okay, which means that here we're going to pass the rule that we already have. Okay, and we're going to modify it. Okay, so inside I write self dot rules. Okay, so we call this variable right here dot append rule. Okay, so this is the function, and what this function will do is once we create a firewall and we want to add a new rule, we're going to call this function, we're going to specify the rule right here, and this function will add the new rule to our set of rules for the firewall. Okay, then I will create another function that will be called packet allowed. Okay, and here I also write self and then packet. Okay, so imagine once we create a firewall, we're gonna have set of rules that we're going to add with this function. Okay, and after that, when we get incoming packets, what we want to do is to compare these incoming packets to our firewall with the rules, and we want to see whether based on our rules those packets are allowed or they are not allowed. Okay, so this will happen with that function right here. So here this packet is going to come from the internet originally. It will come from the internet, it will come to our firewall, and here inside we will make sure whether this packet is allowed or it should be blocked. Okay, and here's how we can do that. So I will do for rules, actually for rule in rules self.rules. Okay, so for every rule inside our allowed rules right here, okay, we want to do the following: if rule dot matches packet, okay, we're gonna return rule dot action. Okay, so what we're doing here is we're saying that if the rule that we have matches with the packet that we have, then so inside our rules we have certain certain part that will say whether this packet is allowed or blocked. So once we find a match, okay, we're going to return the action, whether we allow this packet or block this packet. And if the packet doesn't exist in our rule table, we'll return block. Okay, and so you can see this policy, and based on what you see here, what is the type of this policy? Is this policy allowing all packets that are not specified, or is that policy blocking all the packets that are not specified? What do you think?
It's blocking everything except that which has already been allowed.
Exactly, exactly. So all the packets that are not specified in our rules, they're going to be blocked. So we're not going to accept them. Okay, if I write here allow, this means that we're going to allow all the packets that are not inside our rules. Okay, so here is how we add the rules with this function, and here is how we're building our firewall policy right here. Okay, so Once we have our firewall already set up, now the next thing that we want to build is our rule class. And the rule class is going to be a blueprint of a rule. So this class is going to have certain variables, that all of those variables are going to be applied to every new rule. Okay, so let's build it, and I'm gonna talk while I'm building it so you understand what exactly it does. So actually, before continuing, are there any questions for the firewall class?
Does the rule.action, is there anything connected to the action?
Yeah, so the action you will see later on when we call the rules, but here is the thing. Action is actually going to be a part of the rule class. Okay, so for example, right here, when we add the rules, the rule that will be added will be from this rule class where we're going to specify this action variable. Okay, so this will be a value of the rule. That's why here when you write rule.action, it's going to go to this class and then take the action variable. Okay, so soon you're going to see exactly where the action stays. Okay.
Okay, thank you.
All right, so let's do class rule. Okay, and here I will do def, and here I will create the constructor. So I will do self. So every rule is going to have those variables: protocol, it will have source IP, it will have destination IP, and it will have the action. Okay, so here I will do self dot protocol equals protocol, and actually I'm going to copy and paste those because they're gonna be pretty repetitive, so I will just do that. So this means that once we create a rule, we need to provide the protocol, the source IP, destination IP, and the action once we create a new rule. And the values that we provide, they're going to be assigned to the internal class variables that are going to be with the same name. Okay, so we're building a new rule, and those here are going to be the features that are coming from outside when we call the class. Okay, all right, so once we have a new rule created, now the only thing that we want to do is to add a function for our rule that is really going to make sure that this rule matches, okay, with the incoming packets. So this is pretty much this function right here, okay, the matches function. So I'll do df matches, okay, and I'll do self dot packet, self comma packet, yes, okay. Okay, and here we're going to define, so when a new packet comes, here we're going to define how we're going to check whether the packet that comes matches with the rule. Okay, so you see that here we implement that. Okay, but here we're going to define the rules. So I will do return. Okay, and here let's do the first rule. So packet, okay, protocol. We're going to check if the protocol of the packet that comes is the same as self dot protocol. Okay, so we're going to check if the packet that comes to us has the same protocol as the protocol defined in the rule. And we're going to do this for the rest of the values right here. So we're going to do this for the source IP and destination IP. So I will do packet, okay, and here I write source IP to be equal to self dot source IP. Oops. Yes. Okay, and and let me write here. Okay, and we also want to make sure that the packet destination IP is equal to self dot destination IP. Okay. So this statement here, what is going to return is either true or false, right? So here we return, okay, and here, if those two are equal, we're going to get true, right? Here, if those are equal, we're also going to get true, okay, and if the last two are equal, we're also going to get true. If either of those is false, since we use the AND right here, if either of those is false, then we're going to return false. So if either the protocol, the source, or the destination IP doesn't match with our rule, we'll return false. If all of them match, we're going to return true, okay? All right, so any questions for the rule class? It's actually pretty simple. We're just defining what our rule is, and then we compare it with the packet that comes in from outside. That's it. Okay. So now once we have the blueprint of how a rule looks like and the blueprint of how a firewall looks like, the next thing that we're going to do is to actually use those classes to create our actual objects. Okay, so let's do that. Now, firstly, let's create a firewall from our firewall class. Okay, so now we created a new firewall that is called firewall. Okay, so this object firewall right here, okay, will immediately, once created, we'll immediately have this rules list. Okay, and actually let me just do one thing so you can see it better. So here, since this is an online compiler, you cannot see some of the additional helper functions that are of a real ID. So let me run it in PyCharm and you are going to see a little bit more clear. So I will just move this code. It's exactly the same. Even if you write it here, it's completely fine. But I just want to show you something. So, okay, so here it even noticed that I did some mistakes, but we're going to fix those. Okay. So here, for example, once I create a firewall, if I do firewall dot, okay, and you see that I can do dot rules or dot other rule, right? Because once we created it, it already has the rules list added to it. Let me just fix those packets. Okay, and here. Protocol. Packet, okay. All right. So I'll continue here so you can really see the options. Okay, so we created our firewall that has rules and those two functions that we created inside. Okay, so the next thing that we want to do is what? So since we already have our firewall, now let's add rules to our firewall based on which we're going to filter the traffic. So I will do here add rule. Okay, and when I add the rule, I'm going to do this from our rule class that is right here. Okay, so I will add it right here. Okay, and our rule, so firstly we need to specify a protocol. Okay, so let's do TCP. Okay, after that we need to specify source IP. Okay, so let's do that. So let's say 192.168.1.10. Okay, now then let's specify the destination IP. So this would be, let's say, 8.8.8.8. Okay, and finally we need to specify action. So the action will be whether we allow this packet or not. Okay, so we'll do allow. Okay, so we added here a new rule, and now the rule that we added to our firewall, we also have the matches function assigned to it and all of those variables. Okay, imagine this as a new object, right? A new rule, and here's how a rule is specified. Now I'm just going to add another one. Okay, and for example here we added another rule that if we get a UDP packet that is coming from the same IP address and the destination is the same IP address, we need to block it. Okay, so here we're going to either allow or block the packet based on what is the transport layer protocol. So we're going to block all the UDP packets that are coming from here, and we're gonna allow all the TCP packets that are coming from here. Okay. All right. Now we have defined our rules. We have our firewall created. So what is the next step? What do you think?
We see if it matches.
Yes, exactly. So what we need to do next is we need to create packets that are going to come to us, so we can see if the firewall actually works. So we need to create some incoming packets. We can imagine that they come from the internet. Okay, and after we create those, then we're gonna send them straight to our firewall and see if it works properly. Okay, so I will here create a list of incoming packets. So I will actually write simulate incoming packets. Okay, so let's do packets, incoming packets. Okay, and I'll create the packets as a list. Okay, I mean, you don't need to create as a list. You can even create them like separately as separate variables, but as a list will be more realistic, because in real life many packets come at the same time. So I will create them in a list, and this list will be a list of dictionaries, right? So let's say I will build the first packet. So the first packet will be a dictionary. And I use dictionary here because we can define key and values. For example, here the key will be protocol. Okay, protocol. Okay, and then the value will be TCP. Okay, then the source IP will be let's say 192.168.1.10. Okay, and then the destination IP. Okay, this will be equal to 8.8.8.8. Okay, so this is one packet that is going to come to us. And I want two more packets just so we have some more data and we see what's gonna be accepted and what's gonna be denied. Okay, so this is the traffic, right? So we have the protocol, we have the source IP, and we have the destination IP. Okay, now once we have that, then what we want to do is to send it directly to our firewall. Okay, so I will do for packet in incoming packets. So for every packet here, okay, I will do result equals to firewall dot packet allowed and then packet, and then I will print okay packet, then I will print the name of the packet right here, and I will do is, and now here I want to print whether it's allowed or not, so I will print result. Okay, so before running the program, let's just recap. Let's first try to predict what will going to happen line by line. So first of all, where is our code going to start? Let's first determine this. Once I run the program, where we're going to start? From which line? What do you think?
Would it begin at line 30?
Exactly, yeah. So we'll start from line 30 right here. Then, so we're going to create a new firewall, okay? And after that, this rules list right here that you can see. So we're going to create a new instance of a firewall. And then here in this line, okay, we're going to add a new rule. So what's going to happen is this list right here, okay, will start having two rules, okay. We're going to fill it with the rules that we got right here, okay. After that, these incoming packets will be created, and after that, for every packet, so we're going to take the first incoming packet, and then we're going to send it to this packet allow function, right? So let's say we take the first packet, okay, take this, okay, and then we're going to send it to our firewall and move to this packet allowed function right here, okay. So we're going to go to this function, and after that, for every rule in our rules, so we're going to check this list that will have the rules, okay. So for the first rule right here, we're going to say if the rule, so if this matches the packet, so once we reach here the matches function, we're going to move right here, okay, and we're going to take the protocol of the packet we sent, so TCP, okay, and we're going to try to match it with the protocol of the rule, which is right here, okay. Then we're going to get also the source IP of the packet right here, and we will try to match it with the source IP of our rule. And the same we're going to do with the destination IP. So once this is done, it will either return true or false. Okay, we're gonna go back here, and if this is true, the if statement will continue and we'll move to this line, and we'll return rule.action. So we're gonna go to rule. Okay, so we assess this blueprint. So this is the rule, and we're going to assess the allow variable right here, and we're going to return it. Okay, so once we return it, this will be our result, whether the packet is allowed or not. And here we're going to print whether it's allowed. If this if statement doesn't activate, so there is no match between the packets, between the first three fields of the packets, we're going to return block. Okay, and this is what we're going to see here. Also, the packet here is going to be this one that we're going to print. Okay, so before starting, any questions on how this should work? Okay, so now this was all on theory. Let's see if this is going to be working on practice. Of course, it's possible that I did some typos, so let's see if it works. Okay, so you can see that the script actually works. So what happens here is that the first packet that we sent was allowed. Okay, and this makes sense because this is a TCP packet coming from this IP going to this one. So here we have the allow policy. The second one was a UDP packet, again coming from this IP going to this one. So here we also have a match, but we block it. And finally, here for the last one, we're not going to have a match, so we're just going to block it. If here I put allow, okay, as a policy, this means what would happen if I do that? What will change? Let's have a guess. So which packet is going to change? So right here, see, if there is no match, right? So if this doesn't activate on any of the rules, then we're going to return allow. So what that means?
Does that mean the third on line 38 would be allowed? Because there's no rule for that.
Let's see. Yeah, let's see. Exactly. So now the third packet is going to be allowed, simply because now we changed our policy and we're allowing all the packets that are not matching. Okay, and I provide you the code in Blackboard so you can even experiment with different types of policies and different packets that are incoming, and you can really see how your firewall works. Also, you can add different rules based on IP address, source destination, on those protocols right here. Maybe you want to add some other features of the packets that come, like acknowledgement bit or sync. You can definitely do that and add it to your policy, so your firewall will be more robust than the one that I just built. Okay, so any questions?
I guess I'm still curious about when they return rule.action, and you've defined in the rule class self.action is action.
Yes, right here.
What is the action specifically? Just that it's
so in our case, the action is going to be allow or block, right?
okay.
So here, as you can see, there are 4 elements, right? And we're checking if those 3 are matching with our policy, right? So if you follow where the action goes, so the action here is either allow or block. Okay, so it goes right here as a part of our new rule object. Okay, and you can see right here, when I call rule, I do rule.action. So it's going to take that specific action for the rule that I add. So for example, if I add this rule, rule.action will give me this variable right here, that is allow. Okay, or I can
Okay.
give him block.
Yeah, that makes sense.
Makes sense? Okay.
Thank you.
Yeah, no problem. Any other questions, guys? How does this look? Do you understand now more how firewalls work when you see it in practice? I mean, this is very simple, but I just wanted for you to really understand how you can implement policies and how the incoming traffic comes and how it gets blocked. So does it help you to understand a little bit more what firewall is?
If you were working for a company and you said you're setting up a firewall, it wouldn't necessarily be exactly this, but you'd be looking at those specific IP addresses and source port numbers
Yeah,
and
yeah.
allowing and blocking.
Exactly. Of course, it's going to be way more complicated with way more rules, right? But the implementation will be exactly the same. Okay, so always you're going to have a list of rules. Maybe you have some file that is going to monitor the time of those packets. You have a file that will actually open the packets as they come. So right here, what we're implementing is just a string, but in real life, your packets will come in bits, right? They will come in the physical layer in bits, and then you need to deserialize those bits, read the header, okay, and then compare the header with the rules that you have. Sometimes, if you also read the payload or what is the actual data inside this packet, you might have also different set of rules for this particular payload, right? So yes, this will be the same in real life. It's just that you're going to have more files. Each policy might have its own class. Okay, you also have deserialization and those type of things, but the base rule will be exactly the same. Yeah. All right, guys. Well, this is the final of the today's lecture.